Hi, good morning, everyone. This is Jagdish, Assistant Professor of EC Department, SNS College of Technology, Coimbatore. And today, in our video lecture series, we are going to discuss about the topic directional couplers. So, this topic comes under the unit number one, that is a microwave passive devices of the optical and microwave engineering subject. So, come, let's directly get into the topic. So, what is actually a directional coupler? So, a directional coupler is a device that samples a small amount of microwave power for measurement purposes. The power measurements include incident power, reflected power, VSWR values, etc. So, directional coupler is a four-port waveguide junction consisting of a primary main waveguide and a secondary auxiliary waveguide. So, the following figure shows the image of a directional coupler. So you could see this is the image of a directional coupler where we have port 1, port 2, that is called as a primary waveguide, and port 3 and port 4, which is called as a secondary waveguide. So in this waveguide, inside of this waveguide, we can see the movement of the waves that is mentioned by represented by the arrow mark. So port 1 to port 2, there is a movement, and by the way, from the port 1 to port 2, the port 3 and port 4, we have some separate that's a wave movement. So this is the structure is nothing but of a directional coupler of the operation of the directional coupler. That's a representation. And directional coupler is used to couple the microwave power, which may be unidirectional or bidirectional. So here there is a port 1 is there and port 2 is there, and matched terminations. So we have port 1 and port 2 is there. This is considered as a different ports. Port 1 is one type of a port, and port 2 is another type of port. So to have a matching the terminations, that is a end to end points, that is a port 1 and port 2, we have this matched termination, and the auxiliary output is there, then that is auxiliary arm. So this is a main arm and a hole is there. So this is the simple structure of the directional coupler. So let's have some classroom activity. The slide shows the some rebus puzzle. We have 12 puzzles are there. So we have several groups, as we already formed the team members, right? Team of groups. You discuss with your team members and find out the answer for this puzzle. That is a rebus puzzle, and quickly tell your answers. So whoever coming forward as soon as possible to tell the answers, uh, they will be, they will be announced as the winners. Okay. Okay, let's resume the session. So, we have what so far we discussed what is directional coupler and the structure of the directional coupler we discussed. Now let's see what are the properties of a directional coupler. So all the termination are matched to the ports, and when the power travels from port 1 to port 2, some portion of it gets coupled to port 4 but not to port 3. As it also a bidirectional coupler, when the power travels from port 2 to port 1, some portions of it gets coupled to the port 3 but not to port 4. If the power is incident through port 3, a portion of it's coupled to port 2 but not to port 1. If the power is incident through port 4, a portion of it's coupled to port 1, not port 2. So this is the power property, and ideally, um, the output of port 3 should be 0. However, practically a small amount of power called back power is observed at port 3. The following figure indicates the power flow in the directional coupler. So here we have incident power, that is a Pi in the port 1, and at the output section, the port 2, we have received power, that is a PR. So inside the power, power flow is indicated, and PB, that's a back power, that is the for the port 3, and PF, that's a forward power, which is mentioned as a in port 4. So inside the directional coupler, the waves, right? The directional coupler indicating power waves, power, flows. So here the coupling factor. What is coupling factor? Coupling factor of a direction coupler is the ratio of the incident power to the forward power measured in dB, equal to 10 log base 10 Pi by Pf into decibel. So the directivity of the directional coupler is the ratio of the forward power to the back power measured in dB, D equal to 10 log base 10 PF by PB into decibels. So what is isolation? So it defines the directive properties of a directional coupler. It is the ratio of incident power to the back power measured in dB. I equal to 10 log base 10 Pi by PB into decibel. Isolation in dB equal to coupling factor plus directivity. So this is the two-hole directional coupler diagram. So where we have incident power Pi and PR received power and PB and PF 4344. Everything is mentioned over here. Let's take the assessment. So first question is what is directional coupler? Second question, what draw the directional coupler? And third one, what is isolation? Fourth question, what is coupling factor? And fifth question is what is directivity? Thank you.